also be walking you through some real life examples, and we'll have some projects so that you will appreciate when to use what concept, why you are learning a particular concept, and so on. Being said that, I need to also inform you that for introducing some of the concepts, I'll be taking very simple examples so that you understand really the concepts, and towards the end I will take you through some real life examples to get a feel of why we want to learn all this. Alright, so most importantly, I'm interested in introducing few terminologies. So the first terminology is basically related to something called as representative sample. Okay, so one may wonder like why this is important. So let me take an example of preparing a soup. All right. So then we will explain you the relevance of this example to our statistics course. So assume that you are preparing a soup, or maybe your wife or your mother is preparing your soup. So when actually you are supposed to check whether if the soup is fine, in other words, if you want to find out if the necessary salt has been added and so on and so forth, then you take a teaspoon of the soup that is being prepared, and you assess whether the soup is good for serving. Is it like fine, right? So there are some problems that one can face. So basically the soup, the teaspoon of soup that you are taking to test, so that is something called as basically an exploratory analysis. And the soup, the teaspoon soup that you took is called as the representative sample. Okay, and checking whether the soup has salt in it or not is referred as exploratory analysis. And after you find that okay, there is the soup is not having salt or having more salt, you take a decision, right? So that decision is called as inference. Okay. So let me revisit these analogies because they are extremely important for someone who wants to use statistics in a real life situation. So assume that you are preparing a soup. So you wanted to check if everything is fine, means like you will not be drinking the entire soup to find out if the soup is okay, right? So similarly, you take basically a teaspoon of soup to check if the soup is fine, is it in proper mix, and so on. So the teaspoon of soup that you are taking is referred as basically the representative sample. And once you take the teaspoon of soup, then you check whether salt is added properly, all the vegetable ingredients are in proper mix, and so on. This process is called as exploratory analysis. And based on how the salt and other ingredients are checked using the teaspoon of soup, you make a decision or a inference about the soup as a whole. Okay, so this process is called as inference. Okay, so why is this relevant? Why am I bringing this analogy to what we are going to learn in statistics? Okay, so it's all about data, right? So basically we have a lot of data, and assume that the data that we have is basically the container full of soup. Okay, so most of the time, due to computing limitations or due to several other factors, like the data is not going to stop, it is continuously going to grow, right? So for most of the cases, you will realize that it is not at all possible or virtually impossible to consume all the data. Okay, some reasons being the data is still growing. For instance, you collect some data and the data is still changing tomorrow. So an example is, if suppose you are analyzing some transactions related to say some e-commerce company. So today you may be taking the logs of few customers. So tomorrow you will get few more logs, right? So if you're talking about some analyzing something related to say some financial company, so by using the transactions or whatsoever, then the transactions are keep on going to increase, correct? So if you're going to analyze anything, most of the interesting things and practical things in this world, you will realize like the data still grows, okay? So most of the time you will be taking a sample. So you will not be interested in consuming the entire data, but you will be taking a small sample. So that is what is referred as a representative sample. And after you take the sample, you will check if the relationships between data, or is the data in proper shape, is there a noise in this data, and so on. So this process is referred as exploratory analysis. And using the sample data that you are playing with, you will make a decision with what you want to do with this data. So that process is called as inference. Okay. So again, why is this analogy important? Because coming to our soup analogy, if suppose you don't take the proper sample, for instance, if suppose you are taking the top portion of the soup by just placing your spoon in the top and then without stirring, if you are taking a sample, you will realize like actually there is not much salt, and you will add more salt, and later you will regret that probably you should have stirred well to get a representative sample. Okay. The same analogy works for data. Most of the time when you are conducting an experiment, it is absolutely critical to ensure that you take the representative sample of data. In other words, you should take a random set of data instead of taking the top few rows, or the files in a particular folder only if there are many folders. So you should take a representative sample by steering it well, or by randomizing it well. Okay. So these are few concepts which are important when you are conducting an experiment in statistical world. So to emphasize, a very, very critical point here is like you should be taking a proper sample. So only then your exploratory analysis, which is your understanding of or the efforts that you put to understand how the soup is made, or how the data is looking fine, or so on, you will be relevant to make a inference, which is the decision that you make based upon the exploratory analysis. Okay. So in a data world, we will not take the entire population for most of the studies. We will be taking a representative sample, and using the representative sample, we will be playing with some experiments or get a feel of how the sample looks like, and based upon our understanding, we will take a decision. So just like how important it is to add ingredients and so on and stir it well to check if the ingredients are added properly, so a representative sample is very important when you are playing with data. Okay. So let's move on. So to give you a simple example, why this is important, or what will be the cost of if you don't take a representative sample, I want you people to get excited about this idea, where there was a very leading newspaper around 1940s, okay, and there were two candidates who were competing for these elections. So one person's name is Mr. Franklin D. Roosevelt, and the other person's name is Alf Landon. Okay. So what this newspaper did was they did a polling. Okay, so you know what is meant by polling, right? You guys must be reading this in newspapers, particularly when there are elections and so on. So these guys did some polling with their customers. So at that point in time, the polling, how they conducted was through basically calling their customers using the phone numbers which they have mentioned. And around 1940s, not many people had phones, and so it was basically restricted to people who had only phones. Okay, and they came up with a prediction that basically Mr. Alf London will win when compared to Mr. Franklin D. Roosevelt. Okay, and in the actual election, so basically Alf London lost so their predictions went wrong, and it costed their entire business. Okay, so the basic idea here again to emphasize is coming from our soup example. So the sample that you are taking, okay, is extremely critical. So if you take a wrong sample, then it may cost your business. Okay, so this is something which I want to emphasize before we introduce the terminologies related to statistics, because if you don't get your sample right, then it will spoil the soup, or sometimes it may cost even a business, as we have seen in this example. Okay, so this is basically just to motivate you to understand why this idea is central and very powerful, uh, because this should be the first step that you should be worrying about or carrying whenever like you are interested in speaking about statistics or probability in a real world. You need to find out if the experiment is proper, because many of the times what happens is we typically tend to hurry just because we have got some data. We'll just hurry by loading it in an Excel sheet or in an R framework or using some other statistical package, and we'll be trying to see, okay, what conclusion we can make from it. So the first question rather you should ask is it sampled properly? Okay, because if somebody is giving you bad data, which is not a representation of the actual population. So the representation, we'll call it as a sample, and we'll use the word population in statistics and probability to reflect all the data which is possible for that experiment. Okay, if the sample or the representative sample is not representative, then whatever you do, whatever sophisticated algorithm you do, or whatever acrobatics you do with the data, it is not going to be of much relevant. Okay, so just remember this point. Just put your break when at all you are interested in doing something real time with respect to this concept related to statistics. Okay, so fine. So this not being like a 100-hour module or anything, I'll just sensitize you with some introductory concepts, and I will spend more time in explain the core concepts. So let's move on. So assume that you have done a proper sampling and so on, and now the phase of the project in which you are working on, let's assume that the sample was really actually representative in nature, and then now you want to think about how do we go about playing with this data, right? So I'll be taking you all through some simple concepts. So the first concept is trying to find relationships between the attributes. So as we have already seen before, I was talking about something called as exploratory analysis, right? So you take a a spoonful of soup, and then you check if the soup is proper and so on. So the same concept we will be seeing how to apply it here in this setting. Okay. So let's assume like you have got some data, and assume that say this is some data in this x-axis related to say height of people, and in y-axis for the time assume that it is related to weight of people. Okay. So I'm just trying to highlight something here using the highlighter. Just 1 second. Okay, I think we're good. So let us assume that this axis is basically the height of people, and this axis is probably say the weight of people. Okay, so now we should assume that this data is coming probably say from an Excel sheet. There are two columns. One column is called as height and another column is called as weight. And when you put this data over an XY plot, are also called as say a scatter plot. And if you observe that the line is like this, okay, then you should understand that there is a positive relationship between height and weight. What does that mean? If suppose say the height increases, for example, if you assume this is height from say 1, 2, 3, 4, 5, 6 up to say some 7 or whatever, If the height increases, then the weight, say if it is from 50 to 100, then the weight also increases. Okay, that is an example of positive relation. Okay, there will be some examples of say negative relation, where let's assume there is say in this axis, let us talk about say the number of people in a company, and let's assume if this is say the visibility or the interaction freedom that the employees have. So one can realize that when there are not much people, then you can assume that each of the employees know each of them well. But if the number of employees increase, then the degree of knowing others actually probably may decrease. Okay, so this is again a simple example to demonstrate that concept that there will be some relations which will be negative. Okay, and sometimes it is important to actually understand the shape of relations. So sometimes you will have a shape of relation which is very linear in nature, and some other time the relationship will be curvy. Okay, so this type of relation is called as a linear relation. So if someone is talking about the shape of a relation, you should say that it is either linear, or a better word than curvy is called as non-linear. So if it is linear, you find that there is a straight line and then say it is linear. If it is not in a straight line, then you say that the relationship is actually non-linear. Okay, and one can also talk about the strength of relation. So here in this example, for instance, there are two scenarios. One is basically emphasizing that there is a strong relation. So how to interpret this graph is basically assume that the marks in x-axis, marks which are marked as x, basically these are your observations. So they all are not in the straight line, but still they are very close to the straight line. Hence this relationship is very strong. Okay, so it is like saying that the height of a person, for instance, if it is a 5.5, if his weight is say say 60 kg, there is another one person who is having the same height but having a different weight. Okay, maybe say 65 kg or something. Okay, hope you guys got it. Okay, all right. So sometimes the relationship between the variables might be weak. So when you are collecting data, so you may realize that these guys are the relationship is not actually coming close to the straight line, but it is all dispersed. So for instance, here it is trying to emphasize that say the weight of a person with a similar height is very much different from some other person with the same height. For instance, here it may say like he is 50 kg, here it may say 90 kg. So a person having two people having similar height, the relationship with respect to the relationship with respect to weight is probably weak here. Okay, all right. So the last concept is basically something called as outliers. So if suppose when you are collecting data, if you are realizing that most of the data is in some portion, and except some very few points which are not at all like close to what you are observing for most of the time, then the other points are typically referred as outliers. So you should do some experiments to really find out are they outliers, or are they part of data? Should we do some more experiments in this region, or is it like some wrong reading that I have done, or is that like there is some problem with respect to the spreadsheet or the file which contains this data, particularly for these points. Okay, so these are few things that once you know that you have done a proper sampling, you should be doing with the sample that you have collected. If the data is really not big, then you should do this with the entire data to understand a feel for the data. Okay, because we will see how these concepts are going to help us in statistics and probability also later when we want to apply it to real life problems. But these two ideas are extremely central before we start the statistics and probability vehicle. Okay, so to quickly summarize what we have done, is basically we are trying to emphasize 2 points. Okay, so the first point is sampling is absolutely important. So do a proper sample. Once you are done with this sampling, try to find if the relationship between variables are positive, negative, or what is the shape of relations, what is the strength of relation, and the impact of outliers in your data and so on. Okay, so one thing which I want you guys to understand is the introductive slides might look a little bit slowish and lazy and sluggish, but I want to give a analogy that, like, when you want to learn anything interesting, so let's assume you want to learn English. So the first thing is you will have to learn ABCDs, right? So just like that, for statistics or how to use it in a practical scenario, these concepts are important. So you will appreciate the world of statistics once you are able to put all these thoughts together, and when we are doing a project by solving a real life problem. So stay tuned if you feel like these are looking like some definitions or so on. Okay. At any point in time, if you have any doubts, please feel absolutely free to ping me, and I'll be able to take your questions with some appropriate examples if required. So the last terminology that I want you to understand before we move on to the actual concepts which are the bread and butter of statistics is something called as skewness. Okay. So, right. So when we are talking about skewness, so what I want you to realize is basically the following analogy. So let's assume that we have collected the height of many people. Okay. So I'm just interested in putting my pointer there. Just 1 second. All right. So for the time being, assume that in this axis, in this x-axis, is basically some representation of height. So what is that representation? Basically, in y-axis, assume that it is count. So this bar means that if suppose say this is 10, 0, 10, 20, 30, 40, 50, 60. So this means that there are 5 people. Okay, there are 5 people with this particular height. Okay, so how to interpret this, I will repeat. So assume in this axis basically you have some representation of height, and this axis is the count. So assume that this is height related to 5, 5.1, 5.2, 5.3, 5.4 up to say 7. So this axis, what it is trying to say, this graph, what it is trying to say is there are 5 people. If this is 0, 10, 20, 30, 40 up to 50, it says that there are 5 people, because this is 0 and 10, right? So there are 5 people with the height of 5, and there are close to 9 people with a height of 5.1, and there are say say if this number is say 50, then there are 50 people who are having say height as 6.5 or 7 or whatever. Okay, so if suppose you take this height data and you plotted this figure. Okay, so whenever we are doing something, you should realize that there are statistical packages like R which will be able to do all this for you. But given some small data, to understand this concept, you must convince yourself that you are capable of doing this by yourself with hand. Okay, so computer comes handy when there is some meaningful of amount of data. Since this being a course based on concepts and how you will apply, you should ask me or you should interrupt me if you are not sure about how to go about this problem by solving it hand. Okay, so the problem that I am trying to highlight here is how to create something called as a distribution. So this word will come and haunt us till the end of all these modules. So how to create this distribution is, let's assume by taking a small example. So in the example, what I have what I'm inviting you all to assume is that assume that the x-axis is some representation related to height, and y-axis is some representation related to the count of heights. Okay, so what we are saying here is basically if suppose say this x-axis is having different heights, so let's assume the heights were varying from 5.0 to say 7, and the y-axis is the number of you know the number of people who have this particular height. Okay, okay, so in this example, so here we are saying that if this is from 5 to 7 and if this is a 0 to 50, here we are saying that there are 5 people with height 5 and there are probably say 25 people with height 6 and say there are 50 people with height 7. Okay, so if you take your data and if you are observing this kind of relationship, then this is called as there is some problem with my presentation, I think. Okay. 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 So if the distribution that you are plotting with the data that you have collected is looking like this left-hand side, okay, then that kind of relationship is called as a left skewed distribution. Okay, and if the distribution is looking like this, then that kind of relationship is called as a right skewed distribution. Okay, so this data is left skewed, this is symmetric, and this is right skewed. Okay, so now let us try to think about say some examples of some real life data when this will look like left skewed, when it will look like symmetric, and when it may look like right skewed. Okay, so if suppose say you are you know say measuring some data related to say some common scenario. So let us talk about this being say the say number of people who are traveling in a road, say from morning to say some other time. Okay, so you can realize like at around 6 o'clock the number of people who are traveling will be less, and you know, as the office time goes on, so you will realize like the number of people, if you are measuring the number of people who are traveling, then you will realize like the number of people increase. Okay, so coming to an example of say symmetric distribution, so if suppose say you are conducting a survey in India to find out how many people have water, electricity, and so on and so forth. So so let's talk about say you know collecting some of this data related to this. So you may realize that there are few people who have got who have not got necessary electrical power and so on, and but there are few people who have got this in surplus. So this, if it is an indication of the amount of electricity or power supply or water supply available in a particular region. So you may observe that some regions have, you know, not much supply. Most of the regions have you know decent supply. So because this axis is basically the amount of powers available, right? And you will realize like there are few guys who have you know more than surplus, or their count is less. Okay, that's why this height is less, but the kind of things that they will consume is probably say very high. Okay, coming to an example of right skewed distribution. So if suppose you take in this axis a reflection of the income of user. Okay, okay, so if suppose you are taking this axis as the representation of the income of users, so this kind of tries to say that there are many guys who have got less income. Okay, so because this is income, right? So there are many guys, there is less income, and there are very few guys who have got a lot of income. Okay, so this distribution is called as a right skew distribution. Okay, so the name comes because is based on where the skew is. So here you will realize like it is skewed in a particular end. So there is a question from Mr. Ashish. Okay, so the Ashish question is, but is it to explain his question, let me try to read what he has pinged me. So he says, isn't it dependent on how the data is arranged? The symmetric might get changed to symmetric from right to left or skewed and so on. Correct. So Ashish, your question is correct, but the thing to note is if I have to talk about say the income of users, okay, so most of the time you will be arranging the income from low to high, right? Because that is how typically you naturally represent income. So when somebody says, how is the distribution of income of users going to look like? So it is possible that you might start with a high income and then you end up with a low income, or you may just reflect most of the scenarios like in naturally how you may be representing. So you may start with saying like low income to high income. So if you are arranging from low income to high income, then the distribution might look right skewed, okay, or you may arrange incomes in some particular manner so that it may look like symmetric. But in most of the real life scenario, one does not actually it is not supposed to, we are not supposed to do that, because there should be some order in this data. So assuming that you capture the data in an order which is reflected in the world, we are here referring to the shape of skewness in such a setting. Okay, so hope you understand and able to appreciate why some data will look like symmetric and right or left skewed right now, because here you should assume that you are going to order this x-axis based upon most of the time how you are capturing this data as in the real world. So it is possible that you may start with a high income and end with a low income. That is perfectly fine. But most of the experiments, the data that we measure, how we will organize is typically to reflect to a common man how he will think the range of this data is varying from. Okay. All right. So let's move on. So one central idea which is again important is related to something called as unimodal distribution. So when you are collecting this data, as we have seen in the previous slide, okay, so you may realize that there is one peak. Okay, so you may realize like in the data when you are organizing, there may be say one peak. So if there is only one peak in a distribution of data that you are collecting, that is called as a unimodal distribution. And if the data is looking like flat, the distribution is looking flat, then that distribution is called as a uniform distribution. So if suppose say the data is having two peaks, then it is probably called as a bimodal distribution. If it is having many peaks, then that is a multimodal distribution. Okay. Again, these concepts looks very simple, but these concepts are extremely important when you are planning to apply it some real life situation related to the concepts that you are going to learn in statistics and probability. Okay. So let's talk about say some few examples of when the data might look unimodal. So here we said that if suppose we are taking some general resource availability in a particular region in India or across India, you may realize like there are some regions which doesn't have enough of a particular thing like electricity or power, but there are few regions who has surplus, and most of the region, there will be many regions where the quantity that you are measuring might be adequate. Okay, so coming to an example of uniform distribution, so one may think about say generating say some say some random numbers, and if one is interested in measuring the number of time 1 comes, 2 comes, 3 comes, 4 comes, 4 comes, and 9 comes, so you may realize like there is no one number which is present too much, right? So if you're just interested in finding out the count of each of these numbers when you are rolling a die, or when you are taking say from a bag of numbers, then you will realize like all the numbers has equal chance of being coming. So this is called as a uniform distribution. Okay. So can someone suggest or think about an example of bimodal distribution? Can someone give me an example of when you will be able to come up with some data which might reflect a bimodal situation? All right, so you can think, but to give you a start, I will give you an example. So assume that you are going to your organization where you are working, and you are measuring the height of all the employees who are there. Okay. So for the sake of simplicity, let us assume that the height of girls are say probably less when compared to say the height of boys, or male and female. Okay. So in your data, when you are trying to plot it, if you don't say keep the gender as a variable here, but if you just observe the height of people, so you may observe that say if this is height from say 5 to 7, you may realize like there is a distribution which will say something about the height of say males, and this is something related to the height of females, right? So hope you understand when in a data you may get bimodals. So Praveen has a interesting example. So he is talking about the traffic peaks in morning and evening hours. Okay, so he says that if one has to measure the traffic say from some time to some time, it's an interesting example to emphasize the point that in morning there is a peak, and again as the time progresses, assuming there is some sufficient gap here, as time progresses towards the evening also there is a peak. Okay, so these concepts are important, because when you are learning probability distributions in deep later, if you forget what kind of distribution it is, then your inference will go completely haywire. Okay, so just understand these concepts. And I will not spend time in explaining multimodal. Here we are referring to scenarios where there are actually multiple peaks. Okay, and you may be able to think about an example for this yourself based on the domain from where you're coming. All right, so now comes the bread and butter of statistics. Okay, so here on we will be going to the core concepts in deep. So some important concepts which are very famous, which are very important, which are the bread and butter of statistics, are called as measures of center. Okay, so assume that you have got some data, and you wanted to find out how central is this data. I mean, you wanted to basically, why is learning measures of center important, is because you want to get some quick feel of the data. Okay, means you have got some data, you have made sure that it is a representative sample, and you have tried to understand the relationship between this data and so on. But you also want to get some quick summary of this data. So one may rely on something called as measures of center and measures of spread. So first let us discuss about some measures of center. Okay, so the first measure of center is called as arithmetic average, or is also called as mean. Okay, so this is a very simple concept. We'll not be spending time, and I'm sure absolutely like all of you guys must be able to do this. I mean, so let's assume say the height of a few people are measured as say one person's height is 5 and another person's height is 6, and say the other person's height is say again 5. Okay, so when you're talking about mean or the arithmetic average, you just add these numbers and you divide by the total number. Okay, so this is the arithmetic mean. Okay, so the mean in this case will be 16 by 3, so it may come to say 5 point something, correct? So coming to basically median refers the midpoint of the distribution. Okay, so basically if one has to calculate median, the way to do this is you should sort this number in an ascending order, right? So here you will say that the numbers can be sorted like this. So 5 comma 5 comma 5 6. Okay, so here you will realize that the midpoint of the distribution is this. Okay, through which you can say that 50% of the guys, so let us assume we have got some more data, say 4 and say 6.5 or so on. Okay, okay, so how to calculate median is just sort these numbers and take the middle value. Okay, because that tells about the 50th percentile. So this for instance says that there are 50% of the guys who are less than me, or who are having values less than or equal to me, and 50% of the guys who have got values greater than or equal to me. Okay, so this concept is called as median. Okay, so this is median. Okay, and the last concept related to measures of center is called as mode. Okay, so if you're taking say this example, okay, so in this example mode talks about the most frequent observation. So in this example the mode is basically this number 5. Why? Because 5 is occurring most number of times. Okay, so these three words, three M's, first is mean. You just take all these numbers, add and divide with the total number of observations, that is called as mean. And coming to median, you arrange these numbers and you take the midpoint about from all these numbers. That point is called as the median. And coming to mode, you take the most frequent observation, or that number which is occurring most of the time. So that is called as the mode. Okay, so now let us try to emphasize these concepts using a small quiz. So if you are used to Edureka, then you will be knowing about Annie. So she will be asking some quiz questions once in a while. All right, so let's take this quiz. So if you guys know how to even do this, then that is fine. So for this problem, Annie is asking us to find out the mean, mode and median for the below 10 student exam scores. So assume that these are some scores obtained by students in an exam. So the question which is being asked is we are supposed to compute the mean, median and mode for all the students. Okay. So let's talk about rather than the final solution. So how to do this is basically, if you're talking about mean, you take all these numbers, and in this case there are 10 students. So you take an addition of all this and then you divide by 10. That will give you the mean. And coming to mode, you have to arrange these numbers, and from say here in this case say 45 is the smallest, and then 56. So you arrange the numbers like so you arrange it like first you put 45 and then you put say 56. So like this you arrange all these numbers up to say 98, which I think is the highest here. Okay, and you take the midpoint. So that is the meaning of median. Okay, yeah, so in this case yeah, thanks for finding out the mistake. Okay, so Mehul has calculated it, and he has pinged me that so the answer for say mean might be say 74.2 as per his calculations. Okay, and say the mode is say the median is say 67. Okay, and coming to the mode, basically we have got this number 98 two times, say when compared to any other number. So we will say the mode is 98. Okay, so this is mean and this is median and this is the mode. Okay, so though you will realize towards the end that in R or in Excel you will have options to click it with the mouse of by a simple click in a computer it will be able to spit out all these numbers. But as someone who is interested in statistics and who want to apply it in a real life, it is absolutely important, and I will emphasize this point, that you should be hands-on, okay, for a very small setting, because then your involvement will be more with respect to the problem and you will have a feel of the problem. That is very important, rather than using some packages and libraries as such without understanding what these numbers are actually. Okay. All right, so probably our answers, I think the median, the answer is probably wrong from what one of the participants said. But anyways, I mean, this you can cross-check yourself later. All right. Okay, cool. So let's move on. So now what we have learned is basically something related to measures of center. Okay. So now let us learn the measures of spread. Okay. So when we are talking about measures of spread, here we are trying to capture how diverse or how what is the variation or some concepts related to how much divergence is there in the data. Okay. So I see that some of the participants are pinging me your answers, which is fine. So cool. So by this time, given a data, how to talk about measures of centrality, right? So now let us talk about talking something about the measures of spread. Okay. So there are basically 4 measures of spread, as you can see in this slide. The first measure is related to variance. The second measure being related to standard deviation, and the third measure is called as range, and the fourth measure is called as interquartile range. All right. So the measures of center focus on just getting to a feel of how central is the data, right? So mean gives an indication of the average value, median gives an indication of the 50th percentage, and mode gives the indication of the most frequent observed thing, correct? So the concepts looks very similar, but at this point in time I would assume that you know the clear differences between mean and median and mode, because I have seen in many practical scenarios people use these concepts interchangeably without actually understanding what each means. So they will assume that everything is average and they will mix up things. So but I don't want you guys to have that feeling, so that's why we spend some time. Alright, so coming to measures of spread, let's try to understand all these measures in detail. Okay. So variance measures how far a set of numbers is spread out. Okay. So what does this mean? So let us assume that we take the same example of students' marks. Okay. So we know that say the mean, median, all these are some numbers, that is fine. But now you want to find out how variant are students from mean, mode and median. Okay. So that is what is explained using measures of spread. Okay. So when you are talking about variance, how to calculate this variance? So basically variance is an indication of if suppose say you are measuring few things. Okay. So you may measure that the mean is here. Okay, say you are measuring say the height of people. Okay, so this is a distribution. So let us assume that the distribution is the values are like this, like this and so on. Okay, so now at this point in time, what you have done is probably say trying to find out uh, the so-called mean. Okay, so let us assume this is the place for referring to mean. Now you are interested in finding out how far are these points from this mean, right? So is this points far from here, far from here, and so on. So these ideas, so that can be represented using a concept called as variance. Okay, so how to calculate this variance? Let us assume that this mean that you have calculated, let us assume that it is 6 for this heights example. Okay, so this is a starting from 5 and say if this is a ending till say 8. Okay, and let's assume like the mean height that you are measuring is 6. So when you want to talk about the variance of the heights, what you should do is basically you should say that you know, if the height of few people, if they are say for example say 5.6 and say 7.5, okay, and say 6.5. Okay, so if you were to talk about the variance, let us assume for the time being say the average value here. So in this case I think it is 12, 19, say let's assume it is 20 by 3, it might be say somewhere around 6.5, but for the sake of simplicity let us assume that the mean here is say 6. Okay, so how to calculate variance is basically by doing the following. You take each and every observation, okay, and you subtract it from the mean. Okay, mean is represented using this number, so this actually is an indication of mean. Okay, so this is your mean. Okay, and you take all this observation, subtract from the mean, okay, and you square it. Okay, and then you take the second observation. So in this case it is you're taking 7.5, okay, and you subtract it from the mean here. Okay, so it is again say 6 square, and then you take the last observation, say in this case it is 6.5, okay, and you subtract it from the mean, okay, you square it, okay, and then you divide it with the total number of observations. In this case it is 3. Okay, so this is nothing but what is reflected in this formula. After explaining the formula, I will explain why we should square it and so on, but it is an important question to answer. So how to interpret this formula is this notation is called as summation. Okay, so that is captured using this flavor. So when you are talking about summation, here we are referring to this addition here. Okay, the addition blocks are captured using the summation. Okay, and this is something which we have expressed here. So this is the observation, and this is something like the mean, and you are subtracting it and squaring it, and then you are doing summation for the second observation and so on and so forth. Okay, so whenever you hit some formula like this, now you should be able to stretch it. So you should be able to understand something whenever you are hitting some jargons like this. You should be able to understand what actually it is, and you should be able to use it for a very simple problem. Okay, so now let's come to the question of why do we square it. Okay, so anyways we are just interested in say measuring the dispersion from it, right? So why do we square it? Okay, so let us talk about say this virtual example. Okay, so let us assume that you are collecting say some observations. So let me just choose a color. All right, so let us assume that you are trying to measure whether the stock market is going positively or negatively. Okay, so let us assume that this represents an indication of that, and let's assume like this means it is neutral, okay, and this means it is going very positive, and this means it is going absolutely very positive, and this means like the stock market is going negative, okay, and let's assume here the stock market is going very bad, okay. So now let us assume the data that you are observing is somewhat distributed like this. Most of the days it is neutral. There are few days which is going good and few days which are bad, okay. So now let us try to come to our concept and try to understand why what we have discussed is making sense, okay. So you know that, okay, on an average you can talk about mean and other stuff, but now that we are talking about variance, the point here is to emphasize why there is the square term, okay. So let us for the time being assume that there is no square, okay. So we know that there is some variance, but if suppose in the formula if you assume that there is no square, then how you will do is basically you will say that it is basically 0, say say plus 1, okay, and you will say plus 0 plus 2. Let's assume the observations that you are having, let us assume for the sake of simplicity you have observations like 1, 2, -1 and say 2 for the time being, okay. The problem comes in the next step where it will be 0, -1, right, okay, and again here it will be 0, -2, okay. So if you are not having this square, I'm explaining you the impact of that, okay. So in this case it will say that the variance is 0. So you know that actually the data is having variance, but if you don't square it, then the first use of squaring it is you'll be able to come out of the positive and negative impact, so that this minus will get squared and it will be taken care when you are computing the impact of how divergent is the data, okay. So the other use of why actually squaring is done is basically you wanted to penalize guys proportionally. For example, you want to penalize observations in this area very much when compared to observation in this area. So basically it is trying to emphasize the point that you are interested in penalizing it. So you want to give less penalty to some point which is here, and you want to give extremely high penalty to something which is very far from here, okay. So that is another reason why we square it, all right. Sure. So by this time I assume you have got a feel of what is variance and how to compute it with the help of data. So now let us move on to some other concepts. Before that there is a quiz from Annie. So assume that you have got two distributions, and Annie is saying that there is one distribution which is blue color in nature and is in solid lines. The other distribution is green and is in dotted lines. So the question for you guys is which among the following two curves are more variable? So is this distribution more variable in nature, or is this distribution more variable in nature? Okay. So please share your views or answers. Okay. So here we are talking about how diverging is this data, right? So the answer to this question is green. And even you can check this by, say, assuming some dummy numbers and calculating this. But the basic idea is since we are squaring it to emphasize a point that all these points will get penalized very much. So you can ascertain to yourself that if suppose here we are measuring, say, the height of people, for instance. So here it is saying that probably the height of people is like varying from say 4.5 to say 6. Okay. Whereas in this case here we are talking about a huge variation. Okay, so here we are talking from the height is varying from 1 to 10, okay, which is like a huge variation. Okay, when compared to a variation, it says the height is not varying much. It is most of the time 5, and it is in between, you know, a short uh, uh, arrangement. Okay, so this is called as variance. All right, so let's move on. So coming to a concept called as standard deviation, one thing you will realize is variance as a concept is basically practically not very useful to be communicated to someone. Why? Because the first thing is due to the square term, right? So here we are saying that height as a square. So here we are referring to, you know, something which is squared. Okay, so if you're talking about height squared, then the answer that you will be giving will be the square of the height, right? Because as per the formula we are squaring everything. Okay, so to make a meaningful interpretation, or to make the ideas related to variability simple, what guys have proposed is just to take the square root of the previous formula. Okay, so if you take the same formula and if you just apply the square root term, okay, square root is something which I am assuming you guys know. Okay, and we will not go into how to calculate square root. Okay, so for instance, square root of 4 is 2, square root of 25 is 5, and so on. So basic idea is if you square a number, if you are getting that given number, then that number is basically the square root of the given number. Okay, all right. There is a question from Mehul. In real scenarios, do we mostly use variance or standard deviation? We will be using basically standard deviation for most of the time. Okay, because this is easy to understand. So when I say that the height variance is 25 square, when compared to when I say that the standard deviation is 5, so it makes easy to interpret saying 5, so it will say like if the average height is say 6, when I say the height is height variability is 2, and if 2 is the standard deviation, so I can say that guys will have a deviation of 2 heights here and there, okay, when compared to squaring this number and saying. So standard deviation as a concept is widely used when compared to variance. Okay. All right. So this is something which I find most of the time hard time explaining this, but something which will come very handy if you really understand. So I will require your concentration. Okay. So there is something called as interquartile range. Okay. So here we will use some concepts that we have already learned also. So let us try to understand what is meant by interquartile range. Okay. So interquartile range is basically a very useful concept coming in statistics and probability. Okay. So here you are interested in finding out how variation is in the data in terms of say previously we have seen variance. So the second method is how to talk about this using some ideas related to interquartile range. Okay. So in this concept what is done is basically let's assume you have got a lot of observations. So in this case, for the sake of simplicity, let us try to assume some numbers. So let us assume you have conducted an experiment of say height of people or say weight of people, and you are measuring that weight of people is ranging from, say you have some observation which says say 35, you have an observation which says 25, and so on and so forth. So let us assume this represents the weight of, so in an Excel sheet you can assume that there is a one column, there might be many columns, but for the time being let us assume that there is one column called as weight, and you are interested in creating an interquartile range for this weight. So let us try to understand the formula and then I will tell you where it is used. Okay, so first let us take a view that given some data you are interested in manually creating the interquartile range. Okay, so the first thing that you will do is you will take the median of this value. Okay, So for the time being, for the sake of simplicity, let us assume that the median of this value is, let us assume for the sake of simplicity, say something like 32. This is the median. Then what you do is basically you draw one line. Okay, so if this is like this, you draw a line. This is say 32. I'm explaining the steps here. So the first part is drawing the median line. Okay. Then what you do is basically you try to find out 25% of the points which are less than this and 25% of the points which are greater than this. So basically here I am referring to the 25th percentile value and the 50th percentile value. Okay. So let us assume the 25th percentile value is say somewhere around 25 for the sake of simplicity. Okay. So I draw a line here. Okay. And say let's assume the 50th percentile value, say let us assume that it is somewhere around 38. Okay, then I draw another line here. Okay, now you connect all these lines. Okay, fine. So this is your median and this is your 25th percentile value, this is your 50th percentile, I mean 75th percentile value, because this is the 50th percentile. So this is 25th percentile, this is 50th and this is the 75th. Okay, then this value you take. Okay, so let's assume say the height of this is say 13. Okay, if suppose you take it as 13, I'm just making everything actually approximate. Okay, and you make 1.5 times of this. Okay, many people use 1.5. In this example, you can use say in this let's assume like we are using 1.5, and you draw a small line here. And you here, let's assume the difference that you had is say 3266 into 1.5. So let's make it say 9. So then you make a point, you take it to, say in this case up to say 47. Okay, and you draw another line. Okay, so this plot that you have created put together is called as something called as a box plot. Okay, and the difference between this to this, okay, is referred as the interquartile range. Okay, so I'll quickly emphasize this point again. Basically this is what is introducing interquartile range. Okay, so how to create or how to find out interquartile range given some data points. You take all the data, you find the first you find the median or the 50th percentile value, draw a line. You take 25 percentage points which are less than that, draw a line. Take 25 percentage which is greater than that. In other words, this is here we are essentially referring it to the 25th percentile point which is here, 50th percentile point which is here, and the 75th percentile point which is here. Okay, and then you try to create a box kind of structure. So the interquartile range refers to basically the difference between the 75th percentile and 25th percentile. In other words, the interquartile range will give you a feel of 25% to 75% of the data, how much is basically the the spread. Okay, and to complete something called as a box plot, you take 1.5 times of this region and you multiply this with 1.5 and put a line here. You take, in this case, the say the difference is say 6. So this range I will make it as 9. So that's why from 38 I made a line to 47. Okay, so this is how a box plot is also created. But coming to our measures of variability, the point to understand or the takeaway here is understanding something called as interquartile range. So given some data, you should be able to find the interquartile range. Okay, so this is an example to quickly demonstrate the use of interquartile range. The similar ideas here, the height of this point is not, you can cross check all this. There might be some variation that one may want to plot here also. Okay, But the core idea being here is to introduce the idea of interquartile range, which is basically the essence of values from here to here. Yeah, okay, hope you got it. Okay, all right. So there are two questions, one from Sadesh. What is the use of the 1.5 multiplication? Okay, so basic idea is, you know, if suppose if you didn't do this 1.5 multiplication, and if you would have actually multiplied by only, you have measured say only the, say the 0th percentile and the 100th percentile, okay. And to explain this point, why we are multiplying with 1.5 and also what is the use of this interquartile range. So let us talk about an practical example. Okay, so let us assume that you are working in a domain related to, say, you are working in an e-commerce company which is doing actually shipping of goods. So you are working in a company, let's assume if you order a headphone, you will get a headphone. If you order a book, you will get book, and if you order a TV, you will get TV, and so on. Okay. So let us assume that you are collecting a lot of data, and you have tried to tabulate these data values. Okay. So let us assume for the time being, for the sake of simplicity, that the values that you are observing, this is say an order for say 350 rupees. Okay. So this is an order for 350 rupees. There is an order for 250 rupees. And there is an order for say 500 rupees and so on and so forth. Okay. So now if one has to calculate the variance for say the mean, you can calculate, right? So it may be say somewhere around say 3 point something. Okay. I mean the 300 and something is the mean. Okay. So the mean is basically say close to say 300 say. Okay. And the variation in this case you can calculate. So in this case, let us assume that the variation is, for the sake of simplicity, let us assume that the variation is somewhere around 100. Okay. So here we are trying to imply that a typical variation will be say somewhere between say 200 to 400. Say, let's assume. Okay. And to emphasize the use of interquartile range, let us assume that there are probably say some 25 values which are again kind of replications of this. So let's assume these are books. So there are many people who are ordering say books. Okay, so if it is 350 and so on and so forth. So for the time being, assume that all these values are say in this type. So it's varying from say 200 rupees to say 500 rupees. Okay. Now you are suddenly spotting in the same spreadsheet there is a value which says like this. Okay, so there is an order as reflected in your data sheet which let us assume is mentioned like this. Okay, so actually there are two possibilities, right? One is this data point which has now entered into this sheet. That might be a noise, correct? Somebody could have probably summed it and they have marked that also as probably one of the transaction. It is very much possible, human errors. Okay. The other possibility is the noise could have come through some means. So probably like most of the time you are shipping books only, but once in a year, say somebody ordered from your website, say some say some 3D TV or something like that. Okay. So what happens to our formula for variation? Okay. So in this case, what will happen is if you apply the formula just because of this point, right? Okay. How you will be applying this formula for variance? So you will be subtracting 250 from this point. So let me say it is 10 power 5. Okay. Minus 250. And you will squaring it, right? Okay. So even though the variation is not much for say 99 points, the variation is coming just because only because there is a 1 point. Okay, your variance formula or the standard deviation doesn't give you any indication about this culprit being captured here. You got it? Okay. Whereas if suppose say you are talking about the interquartile range, okay, in such a setting, okay, since we are talking about the values which are from 25th percentile to the 75th percentile, so say this 10 power 5 will be coming in the 100th percentile, right? Okay, it may be coming in the 100th percentile. Okay, so here we are interested in capturing how is most of the data which is centered around the median looking like. Okay, so you may say that if you know that this experiment has noise, okay, so one practical use of this interquartile range is it gives you a flavor of ignoring these extreme cases automatically, correct? Because here we are implying that I'm taking the most frequent observations by taking the values from 25th percentile to the 75th percentile, and hence it gives you a meaningful range of how the data is spread when compared to the plain naive way of arguing out standard deviation, which doesn't capture that an addition of a noise, it will actually spoil the feel of the variance and standard deviation. Whereas this interquartile range, if you know that the experiment has some noise, will give some meaningful basis for it. Okay. So why is this 1.5 multiplication in place? Basically, it's a matter of convenience. At the same time, it is to emphasize that basically, if 25% of the data is like this, then the next 25% of the data probably should be maybe 1 time, or in the worst case 1.5 times more. Okay, if you still get some data which is more than even 1.5 times, then in this box plot it will be represented using some circles. If you have created box plots before or have seen box plots, you will be seeing some pictures like this. The circles represents that your data has points like this. So in this case, if you're talking about the order example, and if this is 300, 400, so or 400, say if the box is ending here, assuming that there is enough space, there may be one box here, one point here, and that will be marked say 10 power 5. Okay, what does this point say is basically there is one point which is not even fitting into 1.5 times of even how the other data is looking like. So box plots tries to give you some quick easy ways to find out outliers also from the data. Okay, so this is the reason for multiplying 1.5. We want to see worst case, let's put even more than one time to see how the data could possibly spread. Okay, so that is the reason. And by this time, I hope like you guys have a feel for when to use this box plot. Okay, cool. All right. So to emphasize this point, when will you use a box plot? If you know that there is an experiment for which there is noise, then you should, apart from considering the variance, you should also try to consider the interquartile range. If you know that the experiment is proper and all the data is like distributed well, then in that case you can still be happy with the variance itself. Okay. So the other point which is important is basically something called as the range, which is nothing but the difference between the maximum and minimum. Okay. So these are few words or few ideas which people use in daily life, and also we will be using it in all the lectures that we are discussing. So these are some central concepts related to statistics. Okay.